Hello everyone, let's look at Leetcode question 1469. Find all the lonely nodes. In a binary tree, a lonely node is a node that's the only child of its parent node. The root of the tree is not lonely because it does not have a parent node. Given the root of a binary tree, return an array containing the values of all the lonely nodes in the tree. Return the list in any order. Okay, so root is the input value, and you can see 4 is the only lonely node because it's the only child of parent node 2. 3 is not lonely because 2 and 3 are both the children of parent node 1. In the second example, lonely node is 2 and 6. 5 and 3 are not lonely because they're both childs of parent node 4. 1 and 4 are not lonely because they're both childs of parent 7. In this last example, all of these blue nodes are lonely children because there are no other children from their parent node. And the constraints are that the number of nodes in the tree is in the range between 1 and 1,000. The node values are between 1 and 1,000,000. Okay, running through the code, we first define if not root, we return an empty array. This is our base case. Then we check if the root.left value exists and not the root.right. This indicates that this is the only child of its parent node because root.right does not exist. In which case, we create a new instance of the getLonelyNodes function pointing at root.left, and we add or append root.left.value to our lonely nodes array. If we currently have an empty lonely nodes array, we simply implement this first node as the lonely node. Similarly, if else root.right and not root.left means that the root.right value exists and left value doesn't, and we have found another lonely node to the right. So we do again create another instance of the getLonelyNodes to the right and add this root.right value to the lonely nodes array. Otherwise, if both left and right values do exist, then we simply call a new instance of the left and right nodes to iterate once more through these conditions. Okay, running through this first example with root value starting at 1, we check the first condition, if not root. This is not true because the root is 1 and it exists. Then we do this next if condition, if root.left exists but not root.right. Nope, that's not true. How about this? If root.right exists but not root.left, nope, that's not true either. Then this else statement must be met then. Create a new instance of getLonelyNodes root.left and a new instance of getLonelyNodes root.right. Okay. Starting with the root.left then, it was a 2. If not root, that's not true. If root.left exists but not root.right, this is not true. How about this? If root.right exists 4 but not root.left, this is actually true. Then return a new instance of getLonelyNodes root.right and add to the lonely node values array list root.right value. So far, since we have no array list, it'd just be 4 for the lonely node right.value. And then we'll finish up this node then because we called a new instance for right. And we check the same thing. Is there something on the left but not the right? That's not true. Is there something on the right but not the left? That's not true. Okay, return 2 new instances for left and right. Okay, we do that and we can see there's nothing, so we return not root empty arrays for both left and right. So that's the end of this iteration. As for 3, the same as the true. There's nothing on left and right, so we return empty arrays. And that's the end of all of the iterations and new instances, so we're ending up with just 4 as our lonely node. Okay, let's look at the second example with root value starting at 7. If not root, that's not true. Next condition, if root.left exists but not root.right, this is not true, there's both left and right. If right exists but not left, that's not true, both exist. Okay, create new instances. GetLonelyNodes root.left, that's 1, and GetLonelyNodes root.right, that's 4. And so we repeat these instances for 1. Let's look at 1 first. If not root, that's not true. If root.left exists, but not root.right, okay, this is true. Left exists, not right. Return a new instance of the root.left value, 6, and add to the lonely nodes the root.left value. Okay, that's 6 so far. So we created a new instance for 6, and we could see left and right won't exist, so we enter our base case, and that's the end of 6, and the left subtree. Now let's look at 4. We said 4 has left and right because the left exists and the right exists, so we enter this else condition. And we do new instances of left, 5, and right, 3. Let's look at 5 first. If left exists, but not right, not true. How about if right exists, but not left, also not true. New instances, we return the base case of empty arrays, and that's the end of 5. As for 3, we say, okay, what about a new instance for 3, not root, that's not true. If root.left exists and not root.right, that's not true. Else if root.right exists too and not root.left, this is true. So we then create a new instance, return self.getLonelyNodes root.right 2 plus root.right value 2. Okay, so we add 2 to our lonely only child array. So far it's 6, 2. Okay, so we created a new instance for 2, and we could see there's nothing for left and right, and we go to this else statement, and we end up at our base case and return empty arrays, and that's it for all of the iterations and new instances. So we're left with 6, 2 as our lonely nodes. All right, let's check the solution. Awesome. So the time complexity is O of n, where n is the number of nodes in the tree. We visit every node exactly once, so that's O of n time complexity. The space complexity is also O of n, because as the recursive calls get the lonely nodes, this results in a call stack size of n in the worst case. This is worst case where the maximum size of n and all the nodes of the tree are lonely. That's it for this problem. Thank you for watching.